Acidity of phenol. After the preparation of or synthesis of phenol, we are going to discuss acidity of phenol. Now, phenol is acid. Why? Because it is reacting with a base, NaOH, which is strong base. So we need a very strong base, very strong alkali to react with this phenol. And this phenol is converted to the phenoxide ion and the water. So this is neutralization reaction. But the same phenol cannot react with NaSO3, which is weak base. So from this reaction, one thing is clear: the phenol is acidic, but weak acid than carboxylic acid. One more thing, it is more acidic than the alcohol, because alcohol is not reacting with NaOH so easily. It is not reacting. So less acidic alcohol. So one thing is clear from this reaction: phenol is acidic, but weak acidic than carboxylic acid and more acidic than the alcohol. Secondly, you have to focus more on this reaction, on this ionization, if you want to consider its acidity. So any acid can give H plus ion. So same is happening with the phenol. So phenol can give H plus ion and form phenoxide ion. So if the forward reaction is more favorable, then and then only this phenol will give more and more H plus ion, and it will be then more acidic, or it will show the acidity. So this is very, very important reaction. So now we have to consider which are the factors responsible for the increase in acidity of the phenol. So if this is a forward reaction, that means if this phenoxide ion is more stable, the reaction is going towards the formation of this phenoxide ion more easily, and that means it is more acidic. So which factor is responsible to increase the stability of this phenoxide ion? And that factor, first of all, we'll see the resonance. If resonance is there, then it can increase the stability of this phenoxide ion by just delocalization of this negative charge. You can see here, this phenoxide ion can give 5 resonating structure where the negative charge is delocalized. That means this negative charge is not concentrated over this one atom, but it is distributed among other atoms. That means this is stabilized by resonance, and because of this phenol can give phenoxide ion more easily. This is not happen in case of alcohols. This is not possible. So because of that, phenol is more acidic, you can say. One more factor, that factor is inductive effect. We have to consider inductive effect to consider its acidity. So we'll divide all substituents into two parts. One is electron releasing group, and another, this is electron releasing group, and this is electron withdrawing group. Electron density is removed from the ring. So for example, nitro group, any halogen or any aldehyde group, so number of groups are there. So you remember, if electron withdrawing group is there, I have shown that group here because that group may be at ortho position, may be at meta position, may be at para position. So if electron withdrawing group is there, it is removing electron density. You can see here, this is unstable because of that negative charge, and any group which is removing that density, that electron density, by just minus I effect, obviously it will increase the stability of this phenoxide ion. And if it is more stable, the reaction will go towards this direction more easily. That means the phenol will give more H plus ion, and obviously it will increase the acidity. So if we can generalize, if electron withdrawing group is present or groups are present on the ring, acidity of the phenol is increased. So that phenol is more acidic. Now, exactly reverse to this. If electron releasing group is attached on the benzene ring, what will happen? So this is unstable because of negative charge, and this group this group you can see here, methyl group, any alkyl group in fact, methoxide ion, ammonium, amino group, these are the groups which are donating electron density to the bridge ring. That means this negative charge is not decreasing, this is increasing because of plus I effect. So in this case, plus I effect is actually destabilizing this phenoxide ion, and if this phenoxide ion is destabilized, this is reluctant to go toward this side. This will not form more easily to get H plus ion, and if less quantity of H plus ion is produced, it is less acidic. If it is less acidic, that means we can draw the conclusion, in presence of electron releasing group, acidity of the phenol decreases, and in presence of electron withdrawing group, acidity of phenol increases. Thank you.